Let's evaluate this integral of the proper rational function, that is 2y power 4 plus 4y squared minus 1 divided by y cubed plus 1 dy. So we have to evaluate this integral. So this basically involves about three steps. That is, in step 1, we are going to perform a long division. Let's do the long division. So I'm taking the numerator polynomial, which is 2y power 4 plus, since I don't have the cube term, I write down this as 0y cube plus 4y squared minus 1. Now this has to be divided by the denominator, which is the divisor polynomial, and that is y cube plus 2y. And in long division, we have to take the first term and divide it by the first term of the divisor. So this gives, we write down 2y power 4 divided by y cube. This equals, we can divide y power 4 divided by y cube. This will be y power 1 using the law of exponents. And so this gives 2y power 1, or otherwise 2y. We put this 2y in the quotient part. Now we multiply this 2y with the terms of the divisor. So y cube times 2y is 2y power 4. We write below this y power 4 term, and then 2y times 2y is 4y squared. We write it below the y squared term. So now we have to do the subtraction. So here we change the sign. Here also we change the sign. 2y power 4 negative 2y power 4. This one is 0. And since we don't have any y cube term, this one is also 0. And 4y squared negative 4y squared, and this is also 0. And finally we have this term, that is negative 1. We cannot divide this negative 1 by y cube plus 1. So we consider this as the remainder. And the quotient is 2y. So we have done this long division, and therefore we can write this as, so the polynomial or the rational function 2y power 4 plus 4y squared minus 1, and this is divided by y cube plus 2y. And so this equals, we write the quotient first. The quotient after long division is 2y. Then we write the remainder, which is a negative 1 here. So I write negative, and this is the remainder divided by the divisor. So this is 1 over the divisor is y cube plus 2y. And so we have written this proper rational fraction as like this after long division. And this completes the step 1. Now let's do step 2. In step 2, we are going to use the method of partial fraction decomposition to rewrite this proper rational function as a sum of partial fractions. So we are going to use partial fraction decomposition method. So let's consider this proper rational fraction, that is 1 over y cube plus 2y. So this can be written as 1 over, we factor y from the denominator polynomial. So when we factor y, we can write this as y squared plus 2. And now using partial fraction decomposition method, this can be written as a divided by y. This is the first term. Then since this quadratic expression cannot be further factored, we can write this as py plus another constant c, and this is over by this expression y squared plus 2. So here we have written this proper rational function as a sum of partial fractions. However, we have to determine the constants a, b, and c. Let's see how to determine the constants. So let's focus this equation. Now I'm going to multiply both sides by this expression so that we can remove the fraction from both sides. And so when we do that, we get 1 on the left side. And this equals, this a has to be multiplied with the term which it doesn't have in the denominator. So it has y in the denominator. So when we multiply both sides with the expression y times of y squared plus 2, this y will get cancelled and a will be multiplied with y squared plus 2. So I'm going to write down this as a multiplied with y squared plus 2 plus as far as this term is concerned, it has y squared plus 2 in the denominator, and compared with the common denominator, that is y times of y squared plus 2, since we multiply with this term, here this y squared plus 2 will get cancelled, and so therefore this expression will be multiplied with y. So I write down this as by plus c times of y. Now let's simplify and determine the values of a, b, and c. So here we have 1, and this equals, let's distribute the a. This will be ay squared plus 2a, and plus let's distribute the y here. This will be by squared plus cy. Now let's group the like terms, y squared and y squared. We have two like terms. So when we factor the y squared, we get a plus b times of y squared. We then write the y term. So this is the only y term. So we write cy plus we then write the constant term. This is 2a is a constant. And so we have set up this equation. Now we can easily determine the values of a, b, and c by comparing the coefficients on both sides. The coefficient of y squared here is a plus b. However, we don't have any coefficient of y squared on the left side. In fact, we can perceive this as 0y squared plus 0y plus 1. And this means a plus b equals the coefficient of y squared, which equals 0. So we are going to get this equation a plus b equals 0. Likewise, when we compare the coefficient of y on both sides, we see that the c equals 0. And so we get c equals 0, which means we determine the value of c. And also the constant term, if we compare, 2a equals 1. So we have this equation 2a equals 1, and it solves for a equals half. If a equals half, when we plug it into this equation, we get the value of b equals negative half. And thus we have determined all the constant, which means we can plug it into this equation so that we write as a sum of partial fractions. And so therefore, we can rewrite this proper rational function, that is 1 over y cube plus 2y, and this equals a divided by y. So a is half. So I replace a by half, and this is divided by y plus by plus c. b is negative half. So this will be negative half times y plus c is 0. So put 0 here. And this is over this denominator, that is y squared plus 2. And this means we can just remove this 0 over here. So this is what we obtained after doing the partial fraction decomposition method. And this completes step 2. Now let's do step 3. Here we integrate. We evaluate the integral. So we are going to rewrite our original integral. After the first step, we have written this. This is the expression equivalent of the expression inside the integral. So therefore, we can rewrite our original integral. That is, the original integral is 2y power 4 plus 4y squared minus 1. So this one is 2y power 4 plus 4y squared minus 1. And this is over y cube plus 2y dy. And this exactly equals, after the long division, we have written this as a 2y minus of this expression. But for this, we are going to use the result from step 2. So let me first put 2y minus, I put this bracket. So we use the result from step 2, that is this expression, that is half y. You can write down this as half times 1 over y, and then this is negative half y. So I put negative half times this is y over y squared plus 2. We close this bracket, and so we have to integrate this with respect to y. Now let's perform the integration. We can rewrite this as a term by term. So first I write down this as a integration of 2y, and then if we distribute this negative, we will get negative of integral of half y dy, 1 over y dy. And then we distribute this negative to here. This will be negative times negative is positive. So we then have integral of half times y divided by y squared plus 2 dy. So we split this as a sum of three integrals. Now let's integral term by term. The integral of 2y, we can factor the 2. So I'm going to write down this 2 out of this integral. We then have to integrate only y. The integral of y is according to the power rule. This is y squared by 2. We can also factor this half out of the integral. So we will have only 1 over y dy. We put this half in front. So integral of 1 over y is natural logarithm of absolute value of y. Plus once again we factor this half out of this integral. So we can put this half over here. Then we have to integrate only y over y squared plus 2. So let's put 1 by 2. I'm going to write this integral as it is, y over y squared plus 2 dy. We also put the integral constant c. Now let's see how to integrate this. We can use the substitution here. That is, we put y squared plus 2 equals u. And this implies when we take the derivatives on both sides, we get 2y dy equals du. Or we can solve for y dy by dividing both sides by 2. So y dy equals du over 2. And this means we can replace this y dy in the integral to du by 2. So let's write this integral. This one is half integral of du by 2, and this is divided by replace y squared plus 2 as u. So we can integrate this. This equals, remember that we have a half here. So this half multiplied with this half will be 1/4. And then this is the integral of 1 over u du. And this equals 1/4 natural logarithm of u. Because if we integrate 1 over u, it is natural logarithm of u. We then replace this u using the substitution that we have already made, which is y squared plus 2. So therefore, this is y squared plus 2. And we found the integral of this expression separately, which we will replace it here. So I'm going to replace this completely. And this equals 1/4 natural logarithm y squared plus 2. So let's write it down here. This is 1/4 natural logarithm of absolute value of y squared plus 2. We can simplify this one. We can cancel this 2 and this 2. So we don't need to write this. So this term is y squared only. This is y squared minus half times natural logarithm of y plus 1/4 times natural logarithm of y squared plus the integral constant c. And so this is the answer to this question.